Friends, this is the lecture number 60. This is the last lecture of irrigation and drainage. So, irrigation planning and management using Cropwat. So, in this we are going to see how a model like irrigation model called a Cropwat can be used to determine the crop water requirement as well as irrigation scheduling for a particular crop, or if you have multiple crops. Okay. So, in this the Cropwat is freely available on internet. So, you can directly download it from FAO site. So, there is a link is given here. You can go through this link and then you can download it and install it in your PCs or laptops and run the model for estimating the crop water requirement and irrigation scheduling. Okay. So, here there is a link. So, you can directly get, or you can Google, type in a Google search engine as Cropwat, then definitely that will lead to software download window or download page, and you can download the software Cropwat. So, here so the Cropwat, so basically it calculates the crop water requirement and irrigation schedules. Okay. So, these two functions of the Cropwat. So, basically it has different modules. There are some input modules and then calculation modules, which also in the same module the outputs are going to display, right. So, basically there are 5 input modules and 3 calculation modules. So, for example, here the evapotranspiration ET0. So, this can be given as input or it can be estimated using some climate parameters or weather data, basically using the Penman-Mondet formula for crop water requirements. And the other one is effective rainfall. So, knowing the rainfall data, the effective rainfall will be calculated based on different criteria. One is fixed percentage or SES curve number. So, all soil conservation SES curve number method and all these things, and crop data for dry crop or rice crop, rice means the wet crop, and soil data input for calculating crop water requirement and irrigation scheduling. Okay. So, and then scheme supply for multiple crops by cropping pattern. So, if you have multiple crops to be irrigated or scheduled, and there is a scheme supply, the calculation available, and Cropwat is wide variety of options for data input and calculation. So, there are several options are available in order to calculate and also they give input, right. And then the structure of Cropwat, if you see this this bar. So, if you open the Cropwat window, so there is a left side, there is a straight bar. You see these are the inputs like climate or ET or rain or crop and soil, right. So, and there is a crop pattern if you have multiple crops. So, these are the inputs, right. So, and the outputs or the calculation window. So, like here the crop water requirement and schedules, okay, and schemes. The schemes basically for crop patterns. So, if you have multiple crops, so that will give outputs. Okay. So, it organized in 8 different modules. So, data input modules there is a 5 and calculation modules 3. Okay. And here the 5 in the 5 in data input modules are 1, 2, 3, 4 and then 5, and the 3 calculation modules are crop water requirement, schedules and schemes. Okay. And the modules are located on module bar. It looks like this, okay, and easy access to modules like climate, crop, soil data for calculation of water requirements, irrigation schedules and supplies. So, if you see the Cropwat window, I mean once you double click the icon on the desktop, a Cropwat. So, it looks like this. So, it can as I explained, it consists of climate, ET0, rain, as these are the inputs, and crop, this is input, soil as input, and crop pattern as input. So, these inputs and the rest CWR. So, these are the outputs like calculation windows, crop water requirement, schedule, and scheme supply. So, these three are the outputs. So, and then the other things, if you look at there is a new, you can open the new window and start. So, then open, okay. So, click on each. If you click on this, right, so this window will appear. So, this is called monthly Penman mounted this one, and the moment if you open it, so there are some files already available. You can click on that and directly you can export that import that data to this data sheet, and then you can click the rain and the crop and the soil. So, all these inputs after giving inputs, and then you can click crop water requirement and the schedule. Okay, if you have multiple crops, you can click crop pattern, and then it will give the schemes. Okay. So, this is a simple and then a very useful tool developed by FAO. Okay. So, here data input modules. So, as I just mentioned, the climate or ET. So, for input measure ET0 and rain for the input of rainfall data and calculation of effective rainfall, and crop, dry crop generally maize, all those things, rice since it is wet crop for the input and crop data and planting dates, and soil for the input of soil data are only needed for irrigation scheduling. Crop pattern for input of cropping pattern for scheme supply calculations, because if you have multiple crops, you can use the crop pattern to decide when to irrigate, how much to irrigate for the particular crop. And calculation modules, crop water requirement for calculating crop water requirements, schedules, dry or wet crop for calculation of irrigation schedules, scheme for calculation of scheme supply based on a specific cropping pattern. Okay, so we are going to see one by one here. So, for example, here the moment you click the climate, right, and this particular window will appear, and then you can punch the input data, or you can also call or import the data from open window, right. So, here for example, this location is given, latitude, longitude, okay, and this station name is given, okay, and then this is the month Jan, February, March, April up to December, and minimum temperature. These are climatic data or climate data, and then once you punch all the data, so the radiation is calculated and ET0 also been calculated. So, you can also give as input. So, these values can be changed during the run. So, this is one, this is to enter climate input data, and the next is rain. So, rain input data. So, it has again there is open, and then once you can also import the data, right, from the existing file. This is the rain monthly rainfall and effective rainfall. So, the method is here the fixed percentage method. For example, here 25 20. So, it is 80%, or you can say 10% is the loss, and then effective rainfall is 80%. So, all case of 80%, 80%, 80%. So, you can also change the effective rainfall method. So, there are some methods available if you see this. So, the methods are here, you go to settings, or So, there is a fixed percentage, sorry. So, if you see this, there is a fixed percentage method 80% as I said. You can also show dependable rain FAO, and there is formulas effective is equal to 0.6 into P minus 10 by 3. Okay, so, this way empirical formulas can be used. USDA soil conservation service and rainfall not considered in irrigation calculation, effective rainfall will be 0. So, if you do not want to use the rainfall into calculations, you can opt for this. Okay. And then the third one is the crop. So, crop input. So, the basically for crop data is called crop coefficients. Okay. So, that is Kc dry and Kc wet. Okay. So, then the stage, nursery stage, land preparation stage, growth stages and the total. Okay. And then root depth so, root depth is given here at the different stages 0.1 at land preparation, I mean exactly initial stage, and then growth stage 0.6 okay, meters, and purling depth, nursery area, critical depletion, yield response, all inputs can be changed, or you can also import from the existing file here. And the next the fourth one is the soil. So, soil input is like soil name and general soil data like Fc minus Wp, the field capacity minus wilting point, maximum rainfall, rain infiltration rate, maximum root depth, initial soil moisture depletion, initial available moisture. Okay. And you can also have some additional data for exclusively for rice if you are choosing for rice. So, you may have to give this data. So, drainable porosity, critical depletion of purling, cracking, maximum percolation rate after purling, water availability of planting, maximum water depth. So, these data needs to be need to be added into the soil input window. Okay. And the next is crop pattern. So, the crop pattern, if you have multiple crops, for example, here one crop groundnut and other one is rice, right. So, you are growing, crop name is given and planting date 04 and harvesting date and area, this is important, area of I mean the crop area per percentages over 100%, how much is the area of a particular crop number 1 and crop number 2. Okay. So, this one, and then model output or calculation windows, calculation file windows. If you see crop water requirement CWR. So, the window looks like ET0 station, rain station, and then this is month on column number 1, decade. So, decade in the sense, so the first decade and first 10 days, second 10 days, third 10 days okay, in a month. So, the decade in the sense first 10 days okay, or 10 days time in decade. So, a stage here, nursery stage, right, all these stages are given, Kc value for different stages, KTC, ETC, the crop water, crop evapotranspiration, and this is a this is the daily basis and this is the decade basis, and effective rain is given, irrigation requirement is given. So, this way you can understand at different growth stages. So, what is the irrigation requirement? So, that is the crop water requirement is calculated for the particular crop. And the next is irrigation scheduling. So, the scheduling window looks like this, the station, I mean the station value and the crop, and then planting date and harvesting date and yield reduction is given, pre-purling, purling and growth stages. So, if you see this irrigation schedule, so 14, 29th, 1st July, 8th July, 21st July. So, like that you have to give irrigation, right, and percolation depletion, net gift and loss and depletion. So, all these things. So, this is the totals the total gross irrigation, total net irrigation, total irrigation losses, all these things you can estimate, like irrigation like efficiency, rain, okay, total rain loss. So, all these things you can calculate using the Cropwat. And the other one is scheme supply. So, if you have multiple crops, so this is the, again you see the station name here, okay, this is the station name, and then crop pattern, for example, rice here, right, rice and groundnut. So, these two were planned. So, this is in June to December, right, and then groundnut, similarly it is a parallel, groundnut also grown, and the net scheme irrigation requirement, irrigated area, and irrigation requirement for actual area. So, all these things can be estimated in using the Cropwat and scheme supply if you have multiple crops. So, this is the this simple model Cropwat, which is developed at FAO, and this is basically used to determine the crop water requirement and irrigation scheduling for both single as well as multiple crops. So, we can see in reality I have installed it in the PC. So, if you can see how it is been used. Okay, so, this is the window, the Cropwat window. Or for example, climate. So, this is the climate window, climate parameters. So, you can open it, and it is already, so once you download and install it. So, the database is already installed in the climate folder. So, then just open it. So, it will give the climate data, the complete minimum max temperature and the station information, and ET0 is calculated using the Penman-Monteith method. You can also check the different methods like options. Go to the options, and there ET Penman-Monteith, there is another method ET calculated from temperature data and other things, and temperature minimum maximum. You can also average temperatures, all these things you can change. Okay. So, and then go to the next input, that is rain. Okay. So, this is the rain, just open it. So, there is a Kurnool, right, KURN 86, you can open it. So, you will get this. There are some other stations also, you can get the rainfall data for other stations, and this is the fixed percentage. You can change that fixed percentage values here, fixed percentage, or you can dependable rain, FAO, empirical formulas, you can change several things here. And there is a chart, you can open the chart and get the the rainfall here, rain and effective rain. So, based on the fixed percentage. Okay. And then a third input is the crop. So, the crop really requires the information on Kc, right, and stage, root depth and everything. So, this is also you can get from this is for rice, right, Kurnool rice, then open it. So, it will give the crop data for rice. Okay. And then go to the soil. So, the soil information also you can get from the soils folder, which is already available. Let us say black clay soil, okay, and you get the information for the black clay soils here. Okay. So, then now the crop water requirement can be estimated using this data, like 1, 2, 3, 4. So, using the 4 inputs like climate, rain and crop and soil, you can estimate crop water requirement. So, this is the crop water requirement for the particular rice crop. This is the first decade, like first 10 days, second 10 days, third 10 days in June month, and this is nursery stage and all this thing, and Kc value, etc., all other values are given. Okay. So, now you can also click chart to see. Right now this is showing irrigation requirement in each month, okay, or each decade, you can say decade in a month. You can also click ET crop. There is a line which is going, it's showing the ET crop, and then you can also see the bar values, ET crop bar values. Let us see the 3D. So, 3D views you can also see. Okay. So, let me close this, right, and now the schedule. So, the schedule will give the when to give irrigation, how much to give irrigation. So, this is the schedule. Oh, okay, I mean this is a fixed window, you cannot change this, maybe you can, now you cannot increase the size also, this one. Okay. So, date, days, days, rain, and all information, that is total grass irrigation, total net irrigation, total irrigation losses, okay, total precipitation losses, actual water used by crop, and potential use by crop, efficient irrigation schedule 100%. So, all information you can get from the irrigation scheduling window. Now, crop pattern. So, crop pattern is the input. So, for example, you have two crops we are grown in the area. So, you can also change the crops here, right. So, click there is a button at the end. So, you can choose there is a number of crops available, you can choose that, and similarly the second crop, this is the rice, right. Now, once you input this, you can go for the scheme. So, the scheme supply, so will give, so this is groundnut, kharif and rice. Okay. So, you can see the June to July. So, all the value this is the precipitation deficit and net scheme irrigation requirement in mm per day. So, irrigation requirement mm per day all and irrigation area 50 and September 100, 50 and 100. Okay. So, irrigation requirement actual area is given. So, this way you can get the information for multiple crops. Okay. So, this is very useful software, you can download it and play with it using the existing data, or if we have some data to analyze irrigation requirement or crop water requirement and irrigation scheduling. So, this is definitely a very good tool to apply in on-farm irrigation planning and management. Okay. No, no and no. Okay. Now, yeah, that is it. So, thank you so much. So, I